Assistant? An assistant? No, you don't need an assistant. Here we go. Draw a right triangle.
You got this. You can do it.
Don't mess up that triangle. Just a right triangle.
See, you already messed up. See, you can't draw a right triangle.
Fill in the right angle and put theta on the lower left on your diagram, Evan. The side across from theta is 9. What is that? Making up its own Greek letters here. There we go. Alright, so the side across from theta is 9, and the other leg is x. Here's what I want you to do. Write theta as a function of x. Write theta as a function of x. In other words, theta equals something in terms of x.
Oh, okay, it's easy.
Yeah. Oh, I see.
Evan, in your best British accent, tell us how you did this one.
Now.
What?
Theta equals inverse tangent of opposite over adjacent.
I think it's caveman.
You input the ratio and it's going to output the angle.
How many agree? Nice job. So, some of you may have started by, you can stay here because we'll give you the second one. Some of you may have started by going back to what you're familiar with. The tangent of theta equals the opposite over the adjacent. Tangent of theta equals 9 over x. But if you're solving for theta, you're going to say, well, theta is the angle whose tangent ratio is, that's inverse tangent, and then the tangent ratio, right? So they say the same thing, just from different perspectives, right? Okay, question?
You put arc cotangent of x over 9.
You could put arc cotangent there, same thing, right? Yep. You can always replace inverse with arc. This means the exact same thing.
So, is tangent, is the inverse of tangent the same thing as a 1 over tangent?
Oh no. You did that on purpose. What's 1 over tangent? That's cotangent. That's just a reciprocal function, right? Arc tangent is switching input-output. Totally different input-output. Now the input is the ratio and the output is the angle.
So like when it says the inverse, no, that's not right. So like if 5 is to the -1, wouldn't that be 1 over 5?
Yeah, that's a different use of that symbol, yeah.
So that's
Yeah.
just a symbol.
That's just a symbol that means inverse tangent. Right. I mean, that's a good point. Sometimes we use -1 to mean, like 5 to the -1 is 1 over 5. That's not what this means. This means the inverse tangent. That's, the input is the ratio, the output is
But I mean,
the
that's how I got it to the other side.
You don't really thinking how you got that again.
This was the thinking. If the tangent of theta is equal to the opposite over the hypotenuse, then the tangent of theta equals 9 over x. But I'm supposed to solve for the angle. Because I said write theta in terms of x. So I gotta write theta equals.
Okay.
So theta equals the angle whose tangent ratio is 9 over x. Remember, that's what inverse tangent means. The angle whose tangent ratio is, and we knew what the tangent ratio was. So now I've written theta in terms of x. We'll do another one. We'll
So
try
that's
another one.
essentially like saying divided by tangent.
No. No, I'm not dividing by anything. I'm rewriting it from the perspective of theta. Let's try it again. Here we go. Draw another right triangle. Draw another right triangle.
Okay.
This time the hypotenuse is 11, and the base, the side adjacent to theta, is x. Let's rewrite theta in terms of x again. So which SOHCAHTOA or TOA are you going to use here? This time we're going to use CA because we have the adjacent and the hypotenuse. You know the ratio. We're trying to find the angle. So theta equals, and Evan has done it. He said that he's even writing out where it came from. He said the cosine of theta is the adjacent over the hypotenuse, which is x over r, which is, in this case, x over 11. And therefore, theta would equal the inverse cosine, or the angle whose cosine ratio is x over 11. There it is. So inverse trig allows you to solve for the angle, get the angle by itself. That's going to be huge for us as we move forward. Bailey, thank you. You can have a seat.
Could he have done theta equals secant to the inverse?
Well, we're going
of
to talk
secant?
about those. We'll talk about those in a moment. But yeah, he could have, but we'll talk
Okay.
about that. Okay. I'm going to send some more people. What time are we at? Before we're done video?
6 minutes.
All right, let's keep it rolling. Anybody who wants to go to the vote?
Okay. Miss you.
And here we go. The inverse secant. The inverse secant of -2. Now, you notice that I did not talk about inverse secant, inverse cotangent, inverse cosecant. I did talk about them when we were doing the graphs, right? The secant, cosecant, cotangent curves. Why didn't I do that here? Because it's so easy to handle. Can you tell me what you're going to do here, your first step? If I ask you to calculate the inverse secant of -2, immediately you should be doing what? The angle whose secant ratio is -2,
Flipping it and writing it to
do it.
Like that.
Guys, if I tell you that the secant ratio is -2, don't you already know the cosine ratio? That's why you don't really need anything for this. You just immediately rewrite it. Anytime you have secant, inverse secant, rewrite it as inverse cosine. Anytime you have inverse cotangent, rewrite it as inverse tangent. Anytime you have inverse cosecant, rewrite it as inverse sine. Why can you do that? Because you're given the ratio, right? When you start with the ratio, it's easy to take the reciprocal of the ratio. You wouldn't do that with angles. They're not reciprocal angles of each other. They're just reciprocal ratios. But if you have the ratio, flip it. So again, if you know that the secant ratio is -2, you also know that the cosine ratio is -1/2. So immediately rewrite the problem as inverse cosine of -1/2, and now it's just like the problems we were doing. Go ahead.
Evan, that makes no sense.
Inverse cosine of -1/2. What quadrant should you draw that in? Well, cosine is negative when you go left. Uh-oh. Cosine is negative when you go left, right? So you should either be in quadrant 2 or 3. However, based on the restrictions from earlier today, inverse cosine is only defined from 0 to 180 degrees or 0 to pi radians. That's either quadrant 1 or 2. So where should you be drawing this? In quadrant 2, right? So label the sides. -1 is your x, 2 is your r, and you're going to solve for the x. Hey, this is a 30, 60, 90 triangle, but you're giving me the answer from the angle in standard position. So the reference angle is 60 degrees. What's the actual angle? 120 degrees or 2 pi over 3 radians. I'm always looking for the angle in standard position.
Oh.
So you found the reference angle, but now find the angle in standard position, so 120 degrees. Good, or 2 pi over 3 radians. All right, let's try another one. The inverse, or let's do the arc cotangent.
Wait, have you been looking for that this whole time?
For these types of problems, yes. Yep.
So it's always just whatever
When it
is
says-
to the line,
Yeah.
whatever it is to the r.
Yeah, yeah, from standard position. So arc cotangent of, I don't know, let's do root 3 over 3. The inverse cotangent of root 3 over 3. Immediately rewrite it. Immediately rewrite it. We didn't talk about inverse cotangent, but we did talk about inverse tangent. So as soon as you see it that it's the inverse cotangent, you're immediately going to say, well, if the cotangent ratio is root 3 over 3, then the tangent ratio is what? And you can rewrite this as the inverse tangent of 3 over root 3. What quadrant are you going to draw that in? Well, tangent is positive in 1 and 3, but arctangent or inverse tangent is only defined in 1 and 4. So where are you drawing this? Quadrant 1. Label the sides. The 3 is the opposite, that's the y. The root 3 is the x, or the adjacent. You can solve for the hypotenuse, you get the square root of 12, which is 2 root 3. Is that a special relationship? Yeah, it is. Look carefully, it is. If you look at it, what special triangle we have here? It's another 30, 60, 90. The smallest side is across from the smallest angle. So the 60 degrees is again the reference angle here, right? And therefore, this time, because it's quadrant 1, the reference angle and the actual angle are exactly the same thing. So how many had 60 degrees or pi over 3 radians? 9. Nice. What time are we up to?
10:38.
Pause it.